Hi guys, and welcome back. So one of the last concepts I wanted to cover in this particular skill is the concept of storage classes. So far we've taken a look at volumes, persistent volume claims, and how those interact with pods. However, one of the cool things about storage classes is that we can actually do dynamic provisioning of volumes on AWS rather than having to explicitly create those volumes and then explicitly create the persistent volume resource and create the persistent volume claim. Instead, what we can do is actually create a persistent volume claim that refers to one of these so-called storage classes, and the provisioner will automatically handle creating the EBS volume and then creating that persistent volume and then binding that over to the persistent volume claim for us. Now, if we were to take a look at storage classes here, essentially what this is a way for us to define a different series of classes of storage that we offer. So this could be, low throughput storage, it could be high throughput storage. If you want to get really granular with the different parameters that you're specifying for your storage, you can certainly do that. When we actually come in to create an EBS volume using the AWS management consoles or any of the APIs that are available, we can actually choose the type of storage right up here. And if we choose something like IO1 or IO2, it actually opens up some other options. So we have the size of storage, of course, but then we also have throughput in terms of IOPS. So if I said I wanted, 500 IOPS, I could plug that in. If I say I want, 10,000 IOPS, I could plug that in as well. And so essentially what we're doing is specifying exactly how many IOPS we want, and we could actually define that as a storage class inside of Kubernetes. Now, if we come over here to our terminal and do a kubectl API resources, we can actually see that a storage class is a type of resource that's persisted in Kubernetes. So right down here, you can see it says storage classes. That's part of the storage provider in Kubernetes. And so that's its own separate resource. So what we can actually do is use kubectl to query for that particular resource from the API server. So if we do kubectl get sc, which is short for storage classes, you'll see that AWS or Amazon EKS rather actually has a default of GP2 available inside of it. Now, the storage class itself has a couple of different options here. It's got the name of the storage class itself. Then we've got something known as a reclaim policy. So basically, once that volume is no longer needed, how do we go about reclaiming it? Do we want to recycle the volume? Do we want to delete the volume and then reprovision a new one when it's requested? So it has a reclaim policy on it as well, and also a binding mode. So what we can actually do is create our own custom storage class in Kubernetes as well as a type of resource. So what we're going to do is actually go ahead and create that inside of our Kubernetes cluster here, and we'll take a look at some of the different parameters. So if you just scroll down a little bit here, you'll see that there is an example of a storage class resource right here, and we're going to go ahead and copy this, and we are going to configure this for AWS or Amazon EBS storage rather. However, you will notice that there are a bunch of different provisioner types that are available as well. So you could go ahead and use any of these that you'd like to. However, I'm just going to kind of stick with some of the basics here for AWS since we're just kind of trying to demonstrate the storage class itself. So I'm going to come in here and go ahead and define a new storage class. So we'll create a file named storageclass.yaml, and then we'll go ahead and paste in this example right here. And then I'm going to call this, let's say Amazon EBS GP3. And instead of using GP2 storage, I'm actually going to use GP3 storage instead. We're going to go ahead and just delete allow volume expansion. We're going to delete our mount options right here as well. And we'll go ahead and save this. Actually, I'm going to change this reclaim policy to delete as well. Go ahead and save this. And then we'll go ahead and try to apply this to our cluster. So I'll do a kubectl apply -- file name storageclass.yaml. And as you can see, we have successfully created a new storage class here. So let's go ahead and query the cluster for that information. So we'll do a kubectl get sc. And as you can see right here, it is been created. However, we have a different volume binding mode as well. So I'm actually going to change this from immediate to wait for first consumer. And that's just consistent with what the default is as well. So I'm going to come over here and we'll just change that volume binding mode. And then we'll go ahead and try to reapply this. We'll do kubectl apply. And as you can see, it is not going to allow me to change this. So I actually have to delete it first and then reapply it. So that is an immutable field, meaning that we just need to delete it and then reapply it. So there we go. Let's requery it and see if that's been created successfully. And sure enough, our volume binding mode is now set to wait for first consumer as well, which is consistent with that default of GP2. And as you probably saw in the previous video, when we created that persistent volume claim, until we actually bound the persistent volume claim to a pod, it wasn't actually being consumed technically. It was just really a separate resource, even though the two resources, the pod and the persistent volume claim, were created in the same file, in the same spec file. So now what we can do is actually start to consume this. And so what we'll do is actually create a persistent volume claim consuming this particular storage class, and it should create a GP3 volume for us. So I'm going to go ahead and actually just copy over my PV claim file here. So we'll do PV claim-sc, just for short for storage class. And then instead of going ahead and specifying the storage size of 1 GB and expecting that to kind of match, what we're going to do is actually add in a specific storage class name here. So if you just hit Control Space to invoke the IntelliSense here, under the persistent volume claim, you'll see that we have this option to specify a storage class name. Now, of course, we're going to want that to match our storage class name here, so I'm just going to copy and paste that over here. And in this case, we're doing something that's known as dynamic provisioning. So rather than having to pre-create the EBS volume and then persist the persistent volume as a resource inside of Kubernetes, by requesting a persistent volume claim with a particular storage class name, it will actually dynamically provision that for us instead. I'm just going to change this over to, let's say, 2 gigs of storage, for example. I'll save that, and then we'll go ahead and apply this. So we'll do a kubectl apply. I'll just, actually not the storage class, rather. It's the pvclaim-sc.yaml. And so that should create us a new persistent volume claim, as well as a new pod that we can use to actually mount that storage, because we already had it mounted when we did that in the previous video. So let's do a kubectl, and we'll do a get pvc. And we should have this one PVC that's been created here. As you can see, it's in the pending state. So let's do a describe and get some more details on that particular resource. And as you can see, we're actually getting an error message here that's saying it failed to provision because it is an invalid AWS volume type of GP3. So why exactly are we seeing that? Well, let's switch over to the documentation for Kubernetes here and take a look at the storage class documentation. And when we take a look at the provisioner here, you can see that we've got all the different provisioner plugins that are available. And if we click into the documentation for AWS EBS, or also known as Amazon Elastic Block Storage, then you'll see that we have some documentation for the different supported types of volumes. And as you can see, GP3 is not currently supported in this list. So what we'll do is go ahead and just plug in something like IO1 storage. And so we'll copy that, and then we can specify something for a property here called IOPS per gigabyte. And that will allow us to define the actual IOPS on the IO1 volume. So let's go ahead and set that in our file here. We'll go ahead and plug that in. So for our storage type in our storage class right here, we'll actually change this to Amazon EBS IO1. And then for the type, we'll plug in IO1. And then we also need to go ahead and plug in IOPS per gigabyte. And let's go ahead and do something like maybe 100 per gigabyte. We'll do IOPS per gigabyte 100 and save that. And it's expecting a string for that, so we'll go ahead and just surround that in quotes as well and save that value. And then let's go ahead and apply this IO1 storage class. So we'll go ahead and just arrow up here and apply the storage class. That should create us a new storage class called EBS IO1. And now we'll go ahead and update our other file, which is our PV claim here, to point to that new storage class name. So let's go ahead and just copy that and paste it in for our storage class name here. And then let's go ahead and delete that, and we'll reapply it. So I'm going to just arrow up to pvclaim-sc. We'll delete that. As you can see, it's deleted our pod as well as our persistent volume claim that was failing. And then we'll go ahead and just reapply that. Oops, not the storage class, but the PV claim SC. And that should recreate our pod and the PV claim. And then we'll go ahead and do a kubectl describe PVC posh PV claim and make sure that it creates successfully. So as you can see, this is just a constraint of AWS. So it's failing to create again, and it's failing to create specifically because IO1 volumes must be at least 4 gigabytes in size. So what we're going to do is go ahead and then update our storage class again, and we'll say, actually not the storage class rather, but we're actually going to update the storage size that we're requesting here to 4 gigabytes instead. And so then we'll just kind of delete that and recreate it again really quick. And that will get around that constraint that we just encountered. So we'll recreate the PV claim, and then we'll do a describe on the PV claim and make sure that it creates successfully. And now it's giving us a different error saying that the IOPS is not matched up to the ratio here, so we can only have a maximum of 50 per gigabyte. So let's go ahead and actually change that in our storage class configuration. So instead of 100, we'll just say maybe like 30, for example, per gigabyte. Because it's per gigabyte, it's not total IOPS. So you got to keep that in mind when you're calculating this stuff out. And then we'll go ahead and reapply our storage class. And as you can see, it's not going to allow us to change the parameters. So we actually have to delete that. We'll delete our storage class, and then we'll reapply that. And then once we've done that, we'll go ahead and just recreate our PVC as well. We'll delete that, and then we'll just reapply the PVC as well. And then let's just do a describe on the PV claim. And so it's currently waiting for the pod to be scheduled. And once the pod is scheduled, you'll see that it actually successfully provisioned a volume using this persistent volume claim. So if we were to switch over to the AWS Management Console at this point and head over to volumes under Elastic Block Storage, you'll actually see that we have this 4 gigabyte volume with the IOPS of 120 because we requested 30 IOPS per gigabyte. That's going to total 120 here. And basically it's automatically created this volume for us. And then it's also going to automatically attach this to the correct node that requires the storage for the pod. So if we take a look at the attachment here, you'll see that there's an attachment to a particular EC2 instance over here, and that is one of the nodes inside of our EKS cluster. So at this point, we should be able to do a kubectl get pods. We'll actually do a describe pods, and we'll go ahead and just describe the pod that we just created with PowerShell running. And so that's going to be, actually do a get pods here. And so we're going to be looking at PV posh right here. Let's do PV posh, we'll do describe pod PV posh. And then if we take a look at it right here, you'll see that it successfully started this. And if we take a look at our mounts, it has successfully created a mount under the bacon directory from posh data, which is our PV claim. So let's go ahead and exec into that. So we're going to do an exec into the pod with the posh container, and we'll run PowerShell. And if we do an ls on /bacon, you can see that that folder actually does exist, and that exists inside of the EBS volume that was automatically provisioned by the storage class. So dynamic provisioning can save you the additional hassle of having to statically provision your EBS volumes and then configure those as persistent volume resources inside of your Kubernetes cluster, and instead rely on dynamic provisioning using simply the storage class as a reference for your PV claim. I hope this has been informative for you, and I'd like to thank you for viewing.